Now it's time to enhance our player class and put in the ability to have more attributes for the player like strength, intelligence, wisdom, but I also want to do it in a way that's customizable. So if your game isn't going to be more like the traditional Dungeons and Dragons one, you can create your own attributes that you're going to use. The way we're going to do that is by creating a GameDetails JSON file, and that's going to hold some information about the game. We'll start out by holding things like the game name and version and the list of attributes, but we're probably going to expand this in the future. The first thing we'll do is open up the solution, and in the engine models directory, create this new player attribute class. This is going to have a key, which is going to be like str for our strength if we have strength as a player attribute. The display name, that would be strength and what we're going to display in the UI. The dice notation for how to roll it, so 3d6 if you want to roll 3 6-sided die. Then the base value and modified value. Once we actually have a player and we get their strength attribute, we're going to want to store their base value and their modified one. The base is the natural one from when we roll the dice. The modified will be as if they have a curse or if they have a potion, a spell enhancing their strength, then that would be modified. For this class, we have some chained constructors. If you notice, here's a constructor for the player attribute class, here's another one, and here's another one. And they all have different sets of parameters. This first one takes in a key, display name, and dice notation. This would be used when we're first creating the attribute for the player. And this is going to, all it does is pass to the next constructor, which takes 4 parameters. The key, display name, dice notation that were passed in, plus we're going to call the dice service and roll the dice to get their base value. So that will go to this constructor with the 4 parameters, which all this does is call the 5 parameter one, passing in the base value, what we rolled from the dice service, as both the base value and the modified value. So this way, when we create a new character and we roll their strength, their base value could be 15 and their modified value is going to be the same since it's a new character and they don't have any curses or enhancements applied. Then we get to the final constructor, which takes in the key, display name, dice notation, base value, and modified value, and sets the properties. When we create a new character, this will eventually be called through the chain, but when you load the character from a saved game, we're going to have all this information. We're going to have their base value and their modified value, and that's going to be populated directly through this function. It won't go through the chain. And then there's also a reroll function here. For the character creation screen, we want to have the ability to reroll this, and this just calls the dice service and gives a new base value and modified value. The next thing we're going to do in the engine project in the game data folder is we're going to create a GameDetails.json folder. Most of our files here are XML, but I'm switching to JSON. It's a bit more popular. Eventually I'll convert the XML files for the game data to JSON ones, but that'll be some future lessons. In here, to start out, we're going to have a name value with the name of the game, the version with the version number, and then we're going to have a list of the player attributes. This open square bracket and close square bracket is how you indicate a list in JSON. This is going to have the default player attributes when we create the character, and here's our strength with the 3d6, intelligence, wisdom, constitution, dexterity, and charisma, all 3 dice 6 with a 3 character key and then a display name. Something to remember is the properties on this file. You want to set these to build action content and copy to output directory. I set it to copy always. You could set it to copy if newer. Copy always is my preferred. It's a small file. It doesn't take a lot to copy it over. Next, in the engine model subdirectory, we're going to create a new GameDetails class. And this is just going to hold the values from this GameDetails.json. So it will be a string property for the name, string property for the version, and then a list of player attributes. And then we have a simple constructor here that takes in the name and the version. We'll get to that one in the next class when we actually load the GameDetails file. Now we'll go into Game Session class in Engine View Models, and we're going to have this read our GameDetails JSON, create a GameDetails object, and then store that as a new GameDetails property. We have the new GameDetails property here on line 26 through 34, and it's pretty much a basic property. We have a backing variable underscore GameDetails. We have our setter, our onPropertyChange notification call. We do have the JSON ignore attribute on this because we're going to load the GameDetails in a separate step. It's not going to be part of the save game. And if we didn't have JSON ignore, then all this GameDetails would be saved in our save game file, and then it would try to load up and instantiate through our load game routine, which we don't want. We want it to instantiate in a separate area. And that separate area is a new function down here on line 210 through 224, Populate GameDetails. This is going to read the GameDetails JSON, create the GameDetails object, and then set it into our property here in the Game Session class. This is a pretty simple function. We read the file, GameDetails.json, and we create a J object for this. This is a Newtonsoft object that lets us reference the attributes and the values in here. Then we're going to set the GameDetails property to a new GameDetails object, and we're going to reference this GameDetails J object, and we're going to say get the name attribute and convert it to string. So it's going to go out here to the JSON file, find this name key, get the value, and convert that to a string and pass that into our constructor for the GameDetails object. And we also get the version, same thing here. Then we're going to say in the GameDetails player attributes, this is a list. It's a collection of objects, which we have here is our key player attributes, and here's our square brackets that indicate a list. We're going to say get each element as a J token, and then from there we're going to create our player attributes. Off of that token, get the key, get the display name, and get the dice notation. So that's going to be this here, get the key, str, display name strength, dice notation 3d6. And that's how we load the GameDetail player attributes collection. We could potentially have created this GameDetails object by using the Newtonsoft deserialize object and just point it to the JSON file and have it build off of the JSON, just directly build a GameDetails object. But we have a problem here because we have these chained constructors in the player attribute. The code was getting a little messy. We could force the deserialize function to use a specific constructor, but then we have that extra constructor hanging out there. It just didn't seem clean to me. So I'm going to go with this method here where we have the manual conversion from JSON into the game object. Eventually this will probably be pulled out into some sort of service, or we'll do it some other way. But right now we have a lot of kind of complex things, a lot of different things in motion to add these custom player attributes. So I'm not going to worry about this for right now. And the last thing we need to do in the game session class is we need to call this populate GameDetails in our game session constructors. We have one here on 147, we add a call to it. And then we have one on 171, we add the call to populate GameDetails. And up at the top, we used to have a version property with a hard-coded value. I've deleted that property because now the version is a property off of GameDetails, so we can get that information elsewhere. Now that we have the GameDetails object loaded, we can go into mainWindow.xaml, and on line 10, where we have the title attribute for the window, we can do a binding to GameDetails.name. So our title should be whatever value is here in the JSON file. This is kind of nice because if you want to have a different game, the idea is eventually you'll have just GameDetails.json, all of your game data, the locations, the monsters, the game items, and then all of your images. You can just deliver that, and the source code, you don't have to change anything. You don't have to recompile, you don't have to modify anything. It will all be configuration driven. At least that's the idea. And since we've removed the version property from game session, we need to go into the test save game service, and on line 19 we used to get the version from game session.version. Now we need to get it from game session.gamedetails.version. And in our save game service on line 152, to get the version property name, we used to look at GameSession.version. Now we have to look at GameSession.GameDetails.version. And that should fix the rest of the code so that it now works with our GameDetails object. One last change I did make in the player class. I was looking at this for preparing it for adding in the player attributes, and the quests and recipes properties I used to set to an empty observable collection in the constructor. I've moved those up to the lines where we declare the properties, just say 37 and 40. You now say after the property get, you do equals new observable collection, quest status, or recipe. This does the same basic thing. It makes sure that our quest property has an empty observable collection. Really doesn't make much of a difference whether you do it up here at the property level or in the constructor, but just kind of looking at it, I think this is a little bit cleaner, a little more obvious, especially if we get to the point where we have multiple constructors. Then we don't have to worry about repeating that initialization in each constructor. So now that we have these changes in place, let's run the game, and we see the name is Scott's Open Source C# RPG, which is what I have here in the GameDetails JSON. If I stop that and change the name to SOS CS RPG and do a rebuild and run it, now the game name is SOS CS RPG. If you do this and you change the name, just make sure that you do a rebuild, because since we only changed the data file, if you just rerun it, Visual Studio doesn't think anything changed, so it doesn't recopy the new GameDetails.json to the output directory. And that's it for this lesson. There are probably going to be probably 3 or 4 more lessons for changing the player attributes, because now we have to put the player attributes into the player class, which means we're going to have to change the save game and the load game functions. We'll need to create a new unit test for the new version for this save game format. And ideally, I want to go into the combat service, because in there we're using the player's dexterity to determine who attacks first and whether they hit or miss. So that's going to be a little interesting, trying to get that to work in a way that's completely customizable. Ideally, we would make it so that the combat logic is also customizable and is stored in GameDetails.json, but I don't have a specific idea for that one yet. We'll see what we come up with when we get there. As always, if you have any questions, you can leave a question or comment on the video or on the support page. Otherwise, I hope to talk to you again soon.